Hey folks, welcome back to AI Unplugged. I'm your host, Travis Freisinger. Today I'm continuing my series, The Rise of the AI Engineer, by diving into one of the most exciting areas, conversational interfaces. Whether it's a simple chatbot or an AI agent handling real world tasks, these interfaces are transforming how we engage with technology. In this episode, we'll explore what conversational interfaces are, the different types, and how prompts act as the glue that holds it all together. We'll also dive into the role of AI engineers in creating systems that range from simple chatbots to complex autonomous agents. Before we dive deeper into the types of conversational interfaces, let's first examine what a conversational interface actually is. Now imagine being able to interact with software as naturally as you speak to a person. That's it. That's the core idea. These interfaces let you use natural language to ask questions, make requests, give instructions with real-time responses that feel intuitive and human-like. But it's not just about having a chat. The real magic happens when these systems understand and process the language in a meaningful way, blending natural conversation with automation. This makes them incredibly powerful for both businesses and individuals, allowing interactions that are far more than just pushing buttons or filling out forms, or responding to questions even. We've come a long way over the early days where chatbots were basically rules-based systems handling some simple tasks. Today's conversational interfaces are powered by advanced LLMs like GPT-4 or Claude, enabling them to understand context, use external tools, and even act independently. So now that we've framed up what a conversational interface is, basically a dialogue between two things that understand language, let's break down the different types, sort of say, kind of different ways of kind of using that foundational building block to engage with LLMs. At the end of the day, not all conversational interfaces are equal. There's kind of a three spectrum range from chatbots to more sophisticated agent type systems and even some tool usage in between. So let's explore these three areas in a little more depth. So starting off, we've got our basic chatbot. Traditionally, these were rule-based systems with responses that were pre-programmed, pretty limited. Even a few years ago, they were pretty rigid, hard to use. If you ever had to go into some kind of customer support web service for, a large internet provider, you may have experienced this. They weren't really very adaptable or with new users or unexpected interactions. They were hard to use. They really put people off. And that is in contrast with today's LLMs, which are super powerful. These big neural networks. They're not restricted to rules. Because they function as probability-based predictors. There's a kind of a different mechanism at play here. Now, LLMs learn from vast amounts of data and generalize patterns to respond in a more flexible, human-like ways. That's kind of the magic. So instead of matching to a specific input or a predefined set of responses, they can generate responses by predicting the most likely sequence of words based on the context of the conversation, which has enabled the shift from in modern chat systems to be able to handle a wider range of queries with greater nuance and adaptability, evolving far beyond the rigid chatbots of the past. That's why we're here talking, right? Is this innate ability for it to have kind of abstracted out the larger patterns in being able to speak to it, to converse with it, to type with it, even send it images, which is interesting, really, if you think about it. So, once we got chat working and things were smooth, the next big push was to see if we could give it tool usage. I'm still a little on the fence. Maybe I don't have a clear set of guidelines as to when I would provide it with tool usage versus program the system to do things. That's all part of the exploration, right? But anyway, tools, this is where things start to get interesting. So instead of simply responding to questions, this level of conversational interface can interact with external tools and systems. So imagine being able to ask a chatbot, what the weather is, but not only being able to give you a response, but it could go cancel all of your day's meetings and book you a lift pass for a ski resort if you happen to live in Colorado like I do. Or maybe it's a little more mundane and just pull some extra data from an internal database. The idea is that it's a game changer because it kind of shifts the role of these interfaces from passive responder to active problem solvers. Now, That might be a slight stretch of terminology, but the idea is there's utility there. So kind of the core problem with just the basic chat dialogue is it's only knows what it's been trained on. And I encountered this pretty soon when I started using a lot of GPT interactions. Thankfully they had released this idea of custom GPTs. So I started making one called WebCat because I wanted to pull in dialogue from before its training data. Sorry, after its training data. So there used to be a period in time where it would say, "Oh, I don't know that because my training data is cut off." Now it's obviously a little more intelligent and it can query the web, and things eventually got there. But for my purposes, I would often want to go, "Hey, I really like this article. I've got some ideas. I'd like to be able to kind of chat with it." And I'd have to copy and paste it in, and sometimes I'd have to go bring images through if they were contextually relevant. So I wrote WebCat. That's kind of one of the first things I started exploring on my GPT with MeStream, and I co-created a real simple Python function that eventually became its tool that it could use to go scrape the web. And I would ask it something like, "Hey, given this website, can you please go bring in the full text and related images into this chat?" And it would do it. Now, there's a little bit of nuance behind how it would scrape it. I used a text reader, a screen reader to pull the text, and some tricks to kind of further pull out the relevant images. But it wasn't big, it wasn't complicated. It kind of generally worked. It was really much just a little tinker project. But that was my first foray into tools and kind of seeing how to expand beyond the kind of the core issue of basic chat. But maybe you're wondering, how do you go from kind of answering questions and simple tool usage to solving like real problems for you? So that's where agents come in, right? This idea combines chat, tools, and some degree of autonomy. Might be for 2 minutes before a human reviews. It might be forever-ish. That's kind of what we're going for. So it's about a system that not only interacts with the user, but can execute tasks and make decisions independently. So these are used in scenarios like customer service, technical support, maybe even managing logistics. I have talked to people experimenting there. So here, the interface is more than just a helper, more than just a convenient way to engage with the system. It becomes capable of managing workflows, responding to dynamic changes, and ideally completing tasks with minimal human intervention. There's still very much this idea of human in the loop, HITL, where it's still going to ask for some kind of human guided input. It'll do its best, but it's likely to surface a prompt at some point. Now, the reason being is at the core, these systems can't learn adaptively. If someone's claiming they have an agentic system that can learn, it's probably some kind of it's gathering input, then thumbs up, thumb down, and that data is being fed to fine tune or retrain at the end of the day. There's no way for the system to respond to that input in real time. That's another big advancement I'm waiting for in itself. But regardless, given the current state of things and looking to the future, there's still one thing that's really constant here, and that's the prompts. So whether I'm interacting with a simple chatbot, even from yesteryear, or a more advanced agentic system, I still need well-structured prompts. And I think that's what's so cool about this is like, I'm talking to the machine like I would talk to a person, and the machines are talking to each other like they would be talking to a person, unless they're using tools. That's kind of the interface there to go to more traditional if-then. But there's this kind of neutral ground that's emerging, and that's really cool to me. So let's dive a little bit deeper into how prompts work, how they're evolving, and especially what to think about when we're integrating with tools. When it comes to conversational interfaces, the better the prompt, the better the system's response. But as LLMs have evolved, so have the complexity of prompts, especially now that we're giving language models the ability to use tools, right? So let's break down what goes into creating an effective prompt. First up, we have clarity and structure. Think of prompts like giving precise instructions to a coworker. Maybe they're new, maybe they're more junior, but you got to guide them through the process. They don't have experience to lean on. So if you're vague, they might misunderstand or deliver something off the mark. But the clearer you are, the better they'll understand the task. For example, instead of saying, "Summarize this," you might say, "Summarize this article in 2 to 3 sentences focusing on key insights related to marketing strategies." This specificity helps the model narrow down its focus and provide more relevant responses. And it's not a single shot thing either, right? You could say summarize this, it gives you something, and you engage in a continuous dialogue. And I think this is the big shift from like Google, where you ask a question, you get a response. This is dialogue. This is that conversational piece to this. So, that's a good foundation. Be clear, be concise, think of it like a junior colleague. Next there is context and background. Think of prompts like giving someone directions. If they don't know where they're starting from, it's hard to get to where they need to go, right? So, same thing with LLMs. They perform better when given some background information that informs the task. This is kind of that RAG piece, but we'll talk about that more later. Probably another episode or two down the line. For instance, instead of saying create a contract, a more effective prompt might be generate a contract for a SaaS provider, including the clauses for intellectual property, service level agreements, and liability limitations. This extra context allows the AI to deliver a response that's more tailored to your needs. And once again, it's dialogue, right? It's not, you must get it right. You could start with create a contract, and then you could say, add in, oh, yeah, it's for SaaS provider, and put some intellectual property clauses in. That comes out third round. You're like, I forgot the SLA stuff and the liability limitations. Can you add that in too? And I think, like I said, that's the beauty of the conversational piece. You don't have to get it right up front. You can continue to refine, and with experience, you'll start dialing in more kind of directed prompts. Which really leads me into, it's just like code. It's you got to tweak it, you got to refine it to get the best result. Let's say you start off with a prompt like analyze this financial report, which is good and fine. After a little poking around, you may realize that the output's not detailed enough, or it's missing a real key element of this that you want it to zero in on. So you could say analyze the financial report, focusing on margins and sale growth compared to last quarter. Awesome. It's going to give you a nice, succinct response in relation to the thing you want to know about. This is guiding the model to produce the insightful outputs. It's not a magic black box. You definitely have to know how to work it. So, like in software, it's just like refactoring. Each iteration gets closer to the optimal solution, and this is where prompt versioning is key. You really need to track those changes and evaluate those performances over time. And there's different concepts there that we'll dig into later. Wait, I guess later's now. I should have maybe scrolled before. That's the joys of writing a script and forgetting what you've written. Anyway, so evaluations and feedback loops. So this is so integral to working with prompts. So evaluating prompts becomes real critical. It's not just about whether the AI is giving you the right response, but whether it's performing the right action, giving you the thing you're looking for. So imagine a customer service system consistently giving the wrong order updates. So let's say it's integrated with the CRM. There's a little bit of tool usage here, and maybe it could signal that the prompt's not right. It's not directing the AI. It could signal a few things. Likely your prompt's probably a little wonky. So by setting up feedback loops for user responses or system logs can provide insights, engineers can refine prompts to ensure robustness and scalability. And that whole little piece kind of fits into a concept called LLM ops, where you've got your prompts to manage their version, you're evaluating them. You've got some sense of like what's flowing through the system and how accurately it's performing. But it's not just all prompts at the end of the day, right? It can't just be like, craft the perfect bit of wordsmithing and the system will just magic something out for you. Absolutely not. This is where things get a little bit more interesting, just slightly under the hood. There's a few parameters to be adjusted that will definitely influence how the model interprets and responds to your prompts. So let's look at these just for the interest of kind of completeness. I don't want to get too technical, too deep, but they're there. And if you're going to be dealing in this space, you should be at least moderately informed. So the first one up is temperature. You can think of this as like the creativity dial for the model. A low temperature will make the model more predictable. So this is great for tasks where accuracy is crucial, like generating legal documents, code generation. Definitely, if you're doing some custom code generation with prompts, turn your temperature down. Just a bit of advice there. Higher temperatures allow for more creativity and are great for brainstorming or creative writing. It's really great for exploring a concept in a little bit more depth. And that's the first one people generally talk about. Then there's another pairing here. I'll call it the top K and top P sampling. I believe you generally deal with one or the other. I can't recall specifically off the top of my head. I'm kind of getting a mental model that's blurred together. So these settings involve, influencing how the model chooses the next word, balancing between reliability and creativity. So top K limits the model to picking from the top K most likely words, while top P dynamically selects words until their combination reaches a probability threshold. Slightly the same concept, just slightly different means to approach that. So how does this top K, top P sampling work together with temperature, right? Like, there's a couple dials here. How do they work together to kind of give me, creative output or, more reliable output? Well, you can think of it this way. The temperature modulates the overall randomness by alternating the sharpness of the token probability distribution. So, big picture. Temperature, kind of the big picture view. Whereas the top P, top K restrict the range of possible next tokens, limiting how random the output can be even when the temperature is set high. So for example, if I have a high temperature and a high K / or P, it's going to generate highly creative, very diverse text, potentially less coherent. Like I've really turned the creativity dials up to 11 here. Versus, having a lower temperature paired with a lower K and P value, it's going to generate more focused, repetitive, and safe text. And then somewhere in the middle is probably where you want it for a lot of kind of creative type tasks. You definitely want it on the lower end for kind of that repeatability. The creativity I would put in the middle, and the higher end stuff, I have no idea. I've never turned things up that high. I'm kind of tempted to go do that now after this. But that's not all, friends. There's also something called model versions. So even if you've got the temperature dialed in, you got your P or K values dialed in, switching models can definitely change that. So for instance, I just got an email today that GPT-4o, the latest model, is being retired in favor of a slightly newer version that's cheaper and got all these other benefits they're touting. Great example there. Now, if I wanted to move from 4.0 to this new latest and greatest model, I'd probably have to lean into my evals to make sure things are accurate, things are flowing, the system's still responding the way I want. I would say model version, temperature, and top P or K need to all be versioned with the prompt. This is all meta information that drives the accuracy of that conversational interface. And then one last step down the ladder. It's not just the chat dialogue. It's not just the user input that's happening, behind any of these big chat bots or any systems you're designing. There's the idea of a system prompt, right? You got a system prompt that's going to frame up how the AI is supposed to behave. For instance, you're a helpful assistant. In resolving customer order issues. Awesome. It knows kind of what it's supposed to do. It's narrowed its focus. It doesn't have to look at the whole world. And, a user could then type in, check the status of order 1, 2, 3, 4, 5. Cool. It's going to go, hey, great. I get that. I got tool integration into the CRM system. Well, I can't speak today. Comes back, tells us the status of the items, and away it goes. Now, you could use a system prompt to constrain it so you can't answer questions about diet, for instance. Like that's where it's going to kind of be able to constrain it a little bit and keep it within a certain bounds. Not guaranteed. There's still need for other mechanisms, but that's the general concept. So all of this shows that building effective prompts is both an art and a science, right? We've got some dials from an engineering perspective, but we still have this art of making sure that things are crafted well and that those dials are turned in. It's all about creating a prompt that leverages the capabilities of an LLM and any additional tooling it might be working with. So by focusing on clarity, the model parameters, and continual refinement, not only is it just experimentation at a systems level, it's experimentation like an artifact level. Engineers can create conversational interfaces that don't just respond, they perform actions and solve problems. Really, that's the goal we're going for, right? This whole problem-solving capability. And I guess performing actions can have utility, but the big picture goal is big problem-solving, semi-autonomous or autonomous systems. And this is the core essence of what drives AI engineers building product. How do I leverage AI to better solve problems now? So, when implemented effectively, these systems offer significant benefit. Well, that's the promise, right? It'll offer significant benefit, enabling businesses and users to streamline their workflows, make better decisions, and improve the overall experience. And it'll likely take smaller, more babyish steps to get there than what we're hoping for. This whole next 3 years thing, I'd call it the next 10 years to get there. But we're working on it, we're figuring it out. Now that we've covered prompts and tools, let's kind of, go up the stack a little bit and explore how conversational interfaces are reshaping the user experience. I wasn't going to just talk about the tech, right? I think there's something really important here I want to hone in on. It's not just about a new technology and integrating that. It's about how it fundamentally changes users' interactions with systems. I really think that design is going to have an even more critical role to play as we continue to engineer products with AI in them. So what are the areas that are going to be impacted? Well, there's a natural, intuitive interaction, right? Conversational interfaces replace traditional menus, forms with natural language, and that comes with its own concerns and benefits. But it, arguably makes the technology more accessible, especially for those who maybe aren't tech savvy. It simplifies interactions and it lowers the barrier to entry, broadening usability. We put menus and buttons there because we needed a way to interact with the machines, but now if they can have a dialogue, maybe it's a little bit easier. How do you tailor that to less inclined users versus more experienced? I don't know. I think that's some of the stuff we're going to have to uncover. What other areas is it impacting? Contextual and personalized experiences. These systems remember context, information about you, previous conversations, enabling more personalized and efficient interactions. For instance, customer support agents can recall previous orders, anticipating user needs, and offering tailored recommendations. Really interested to see how that one plays out. Real-time problem solving. So, instead of navigating the FAQs or the forums, the user can ask the AI directly to solve issues like potentially resetting a password, streamlining the problem-solving process. I use it a lot in just kind of general research and querying this way, right? Like, I have need, ask LLM. Oh, look at that, it gave me the thing. I didn't have to go to Google and type it in and then go to a whole third link on Stack Overflow, because the first two are garbage, to find my answer. Enhancing accessibility. So, the use of conversational interfaces will improve accessibility for those maybe who struggle with traditional interfaces. You've got problems with vision and you need a screen reader. This offers a more inclusive experience for those who prefer voice or who have, certain hurdles or disabilities that make it just more difficult to do. I'm really excited about that. I think that's really cool. I think there's a lot of potential kind of maybe leveling out the technology experience there. And then the last one is kind of an interesting one, but I think it's an important one. Emotional engagement and trust. I think this is really where a lot of potential for generative AI in the future rest, specifically around this idea of conversation. So, a well-designed interface fosters trust by providing clear, helpful resources and responses. It creates a positive emotional connection. And over time, this builds loyalty and enhances user engagement. I can definitely attest to this in some of the AI tools I use. The ones that don't give me very good responses, seem designed kludgily, I don't ever go back to. The ones that are designed well, I use every day and I can't get enough of. That's me. That's kind of, what I'm saying. I think there's a real deep need here to kind of dig further on these elements. But outside of the areas it's impacting, what are the challenges? Well, one of the biggest challenges is latency. Now, this is a technical thing, but it does surface into the user experience realm, right? How fast or how slow the AI responds. Speed is crucial. Like, quick responses keep users engaged. Delay can break the flow, frustrating users, doesn't build on that element of trust. Latency also affects how intelligent the AI feels, with slower responses seeming less capable. Engineers need to balance speed with accuracy, finding strategies, that help indicate progress towards solving the the issue, maybe like partial responses, maybe leaning into Grok. GROQ. I'll put a link in the description. It's one of the companies out there trying to solve the inference problem, or basically the speed problem, on how quickly these things can respond. It's experimental. I think there's a console you can play around with. It looks cool, looks interesting. It is substantially faster. In some cases, not always the most accurate, I'd say 100%, but it's interesting that we're pushing on that in different ways. But I think that's still an issue within the user experience. Folks need to understand, they need to grapple with, they need to find ways to make that happen. A great example is like, in ChatGPT or Claude, it doesn't just wait and give you a spinner and then spit out a whole bunch of text. It does like that stream text. I call it the typewriter text, where you can kind of see the keystrokes coming on the screen, and it feels like you're kind of reading a teleprompter type narration. It's a great way of keeping me engaged without making me wait. So overall, conversational interfaces are going to revolutionize how users interact with the system by simplifying complex tasks, personalizing the experience, improving accessibility. But, as in all things, responsiveness remains key, minimizing latency, ensuring these interactions feel seamless, natural, and coherent, all help with boosting user trust and engagement, and hopefully, adoption of AI products. Talk through what a conversational interface is, basics of prompt design, tool usage, and some of the dials you can turn, impact of this idea of conversational interfaces on user experience, and let's kind of round our way up to agents. The idea of agentic AI systems is that it goes beyond just responding to my input. They're designed to act semi-autonomously, potentially autonomously, proactively solve problems and or handle tasks without consistent human oversight. They're more than just reactive systems. They're built to take initiative and perform actions on behalf of users. And guess what? They use conversational interfaces to talk to each other. You may have 3 or 4 different agents having a dialogue about something they're trying to solve. So, how do AI engineers build with agents? The process starts with all things defining the scope, figuring out what you can make autonomous, focusing on the areas that you really, feel are high value for automation. For example, a support agent might handle customer tickets by categorizing them, responding to basic inquiries, escalating complex issues to humans, and following up unresolved cases. It's got a workflow. It's got kind of a standard bucket of things. It's got a job description or a set of tasks at the very least. The e-commerce situation, an agent could monitor stock levels and automatically reorder products when inventory runs low. You could do that with a scheduled task probably too. I'm just giving examples here. I'm not saying they're perfect. So how do I start as an engineer? How do I start to figure out what's a good problem? I would think, from my perspective, identifying repetitive tasks that are currently manual and would benefit from automation. Standard, how do I automate something? Step 1, identify the task. Identify the interactions in that flow and outline how the agents will process inputs, interact with tools or data, and execute tasks. Now, this doesn't have to be as specific as designing like a REST API or a full CRM type system, but you got to have some idea how you're going to put the big pieces together, right? Integrate external tools like CRMs, databases, or APIs to enable the agent to perform specific functions. Tool usage and agents, kind of important. Otherwise, what is it doing? And then set up feedback loops to monitor the agent's decision-making based on real-world outcomes. I think it's important to all of this. You got to keep monitoring these systems, observability, testability, experimentation, overly key. For example, an AI agent might be placed in an HR system, might handle onboarding by automatically sending out the required documents, training sessions, schedules, ensuring compliance with policies, all without human intervention. This sounds like a great space to automate. Change jobs, you got to go in and give them your documents, fill in the tax forms. It'd be really nice if they just could do that. Now, that could possibly be a different type of automation, but I think, the agentic piece starts to open up a few different doors than just a coded workflow. This is going to require conversational capabilities for interaction, tool use for executing tasks, making agents a key player. You may have oversight agents. Maybe there's a QA agent sitting in all that mix, checking everyone's work to make sure it's working correctly, where that would have maybe been a human task. It's a way of kind of further enhancing the autonomy of the system. So outside of customer support, there's a handful of other problems. Sales and marketing, assisting with lead generation by managing inbound inquiries, identifying prospects, sending up follow-up emails. It's dealing with unstructured data, right? Emails aren't structured. It's like it's in the space trying to ingest this information, work through it through conversation. Supply chain management, monitoring inventory, reordering stock, all without oversight, doing it in real time, ingesting this information, and just general task automation, logistics, HR, IT. You might have an IT agent that monitors health and resolves minor network issues or reboots the services automatically when needed. A little bit better than like just a ping test and reboot if you can't get there or something silly like that. It's about giving it a little bit more autonomy in this type of automation. That's cool, but what are the challenges? Like, there's always going to be challenges, right? And I think there's no shortage of challenges in this space. Agents come into their own set of challenges, specifically around contextual understanding. So ensuring that the agent understands the full context of the situation, this is probably the single biggest hurdle. For instance, a support agent might miss the bigger picture if it doesn't recognize that a seemingly small issue is part of a more complex problem. They're not problem-solving machines, right? They're pattern recognition machines that just so happens to sometimes solve problems. Engineers need to build in feedback mechanisms and monitoring systems to help agents adapt to new context over time. This might be some fine-tuning of the models that you're using. It might be more oversight within the agentic system. There's a few different ways this can break down. I'm not an expert. Remember, I'm just an AI adventurer telling you about my adventures at the end of the day. And this is the way I'm seeing the landscape right now. Tools integration, of course, right? What good are agents without tools? They're going to depend on tools to carry out their task, whether it's a database, API. It can be challenging if there's issues with latency, reliability, security, but seamless integration is generally crucial for an agent's success. Maybe it can just run code and build its own tools. Another big one is decision-making boundaries, right? Defining clear limits on when an agent can act autonomously and when they should defer to human oversight. And I think a lot of the agentic frameworks out there are really kind of doing a decent job at trying to surface this. So without these boundaries, agents could make decisions that negatively impact users or the business. For example, a sales agent might offer an exclusive discount to close a deal. This has happened. $1 plane ticket, right? Or a support agent could mishandle a sensitive customer case. These are worries. Engineers often would want to set confidence thresholds, allowing an agent to act autonomously only when they have high confidence in their decisions. I'm sure there are other patterns in there we could talk about as we continue to explore this space. Other impact would be scalability and real-time processing. No, that's not right. Processing. There we go. As agents interact with more users, scalability would become a concern. Cost as well, right? These aren't for free. Maybe you're running some local, smaller models. They need to produce data in real time, handle multiple conversations concurrently, provide fast, actual responses, all while managing a computational workload and optimizing latency for a smooth user experience. Especially when external systems are involved, and maybe you're only relying on OpenAI because that's the version that works with all the dials and prompts that you have. Right? It's a tough challenge. I would love to see these things. I would love to say, oh, I've seen them scale well. I've seen some systems out there. It's still very much an exploratory space, in my opinion. I know systems perfect, so error handling. How does an agent respond when there's an exception, or an error, or a misinterpretation, or a tool failure, or any of the other things that can go wrong in software? A well-designed agentic system should handle this gracefully, recover from mistakes, escalate the issue to a human, or maybe keep retrying. And then finally, in all our conversational interactions with software, even people, trust and transparency become critical. So building trust with the user is challenging. They need to feel confident. They need to make sure that the agent's making the right decisions. The agent should provide explanations. Explainability is the thing I really lean into for trust and transparency in AI interactions. Can it tell me what it did? And funny enough, in doing so, sometimes it can make corrections. Side tangent, there's a reel that was going around about, LLMs don't know how many R's are in strawberry. 3, right? You ask it, how many R's are in strawberry? It says 2, very confidently. Do with tokenizing and a whole bunch of stuff. But if you follow up and say, that's incorrect, can you please explain your reasoning? Or even if you just say, can you please explain your reasoning? It will self-correct. It'll go, oh, no, you're right. Actually, there's 3. And there's a whole series of other little fun exercises like that where once you poke at it and you ask it to explain itself, it starts to kind of rewind and correct its mistake. Not saying that that's going to fix all the problems. Like I said, even in human communication, trust and transparency are issues that we all work towards improving. So what does that mean for agents? What's next? They're growing more sophisticated. Their applicable use is expanding. So I'd like to think in the future we'll see agents taking on more complex decision-making roles, more collaborating with humans as true partners rather than just automation tools. I would say robots are coming into the house. I can't remember the company off the top of my head. Maybe some humanoid robots with some agentic stuff happening could be interesting. That's probably not in my lifetime, but one can hope. Didn't think we'd see this level of AI in my lifetime, so who knows? So to achieve this, AI engineers need to continue refining agents' contextual understanding, improving tool integration, addressing edge cases where human oversight's needed. There's a whole world of things to unpack, right? We're just starting to understand this way of writing software, and to think, 30 years ago I was worrying about managing memory, malloc and dealloc. Anyway, it's a wonderful new world, and the opportunities for innovation are immense and endless. So at the end of the day, AI agents aren't just an extension of conversational interfaces. They represent the future of autonomous decision-making. I think that's why there's so much hope for them. So by designing agents with the right balance of autonomy, tool integration, and user oversight, AI engineers can unlock new ways to automate, optimize, and scale business operations. So we've explored how AI agents operate, the types of problems they can solve, but there's a really key question that still remains. Why? Why would I use AI agents over traditional automation? Automation it's been streamlining processes for decades, reducing manual work, boosting efficiency, the reason we write so much software. However, AI agents offer a whole new level of flexibility, intelligence, and adaptability, right? So just kind of like the chatbots of old, where they're very rules-based, and you go outside rule, and there's problem. Agentic systems kind of offer the LLM equivalent of that, right? That ability to be a bit more dynamic, a bit more intelligent, a bit less rigid in how we apply them to automation of problems. So I would say that, from my point of view, AI agents have the potential to outperform traditional automation in 5 key areas, right? So dynamic decision-making versus rule-based automation. This is the big one that people reach for. Traditional automation follows predefined rules. If X, do Y. And while this works for repetitive, structured tasks, it often falls short in dynamic, ever-changing environments. AI agents, on the other hand, adapt to the situation. They don't just follow static workflows. They make decisions based on current data and context. For example, in customer service, a traditional system might escalate a complex issue to a human agent every time. But an AI agent can troubleshoot first, escalate only when absolutely necessary. So, they're taking some of that workload away from the person. They don't have to put eyes on it every time. Maybe there's a class of problems that the AI agent is pretty good at being able to diagnose and solve. Like, this dynamic adjustment is what sets an AI agent apart, making it, far more efficient and capable. At least that's the goal, right? Flexibility and scalability. So traditional automation is rigid. Once workflows are set, changes require manual reprogramming. Even if you have a workflow engine, I've built some, I've used some. It's not as smooth and magical as everyone would hope for. It does offer some level of flexibility, but ultimately there's still a lot of human intervention, right? So this limits the adaptability to new business needs. Got to hire a bunch of expensive programmers. That's a whole other thing about AI assisted development and reducing costs. But anyway, where in contrast, AI agents are inherently flexible. That's the goal. They can handle a broad range of tasks, from responding to customer inquiries to managing inventory to generally doing things that they've been framed up to do, without needing constant reconfiguration. Also, that's the goal. Moreover, they can scale effortlessly, handling simultaneous tasks and adjusting to fluctuations in workload in real time. To a degree, I'd imagine. Something that more traditional automation can struggle with. We are working on improving that with certain like DevOpsy type things, but nothing's always scalability is never a given in a system. Point three, traditional automation lacks contextual awareness. It just simply follows a series of steps without adjusting based on the broader situation. An AI agent can bring context into the equation. They remember previous interactions, they analyze new inputs, adjust their responses. Where in customer service example, an AI agent could recognize a user's history or anticipate future issues, offering a more intelligent and personalized experience. I think the counter to that is, while they might be less static in their execution, they're constantly solving the same problem, right? Wouldn't it be kind of neat to combine the two where it's contextually aware and once it's known, because it doesn't have a feedback mechanism unless a human's involved, and it's aware that it's solved this problem this way this many times, it can start to build out its own, maybe more static roots in the problem solving. Anyway, I'm kind of off speculating the future here. Another area where it really excels is in handling unstructured data. I mean, this is really the the big issue in AI machine learning, right? Typical automation requires a lot of structure, a lot of structure to the data. So much so that we call things like contracts, interfaces, where agents can handle text, images, voice, all pretty seamlessly. You've got a multimodal model, or maybe you've got specific models you need. So this lack of rigidity in its required structure allows the machine to extract more meaning, to work with this information, to kind of apply those deep patterns it has in its neural network to the problem at hand. Right? It doesn't solve the issue of poorly formatted PDFs. You might still need some kind of unstructured processing tool to get that level of information out, but it's a step in the right direction. The idea is like I need less surety in how I exchange information. I think there's an advantage to be exploited there. And lastly, I just want to touch on proactive problem solving. Traditional automations are reactive. They perform the task when triggered, where AI systems could go a bit further by being proactive. They could monitor systems, anticipate potential issues, and act on them before a problem arises. So, for instance, an AI agent managing an e-commerce platform might detect a spike in traffic and automatically scale up the server capacity. Obviously, you could do some of that, some DevOps practices, but you get the idea. In the supply chain management, an agent could predict stock shortages and reorder supplies before operations are affected. You could probably write an automated task. I'm not saying you couldn't achieve any of these things with traditional automation. I just think there's a leveling up of what you can solve by applying agentic automation to these commonly automated spaces. Well, at the end of the day, AI agents bring much more to the table than just traditional automation, or at least the promise of it. We're still exploring, we're still working, things are moving. There's a flexibility and adaptability, and an ability to handle unstructured data while continuously, I would say, learning, but it's not really. I think that's the piece we need to work on a little bit more. Well, we're continuously trying to become better. I think that's a better way of putting it, because ultimately the underlying pieces are going to continue to improve, which means the overall system continues to improve. Agents don't just execute tasks, they solve problems. That's the promise. They manage complexity and make intelligent decisions in the system. one of the motivations for why businesses are exploring AI-powered agents, not just as a replacement for traditional automation, but as a new way to enhance their operations. All right, so what's the takeaway? What am I getting at here? Ultimately, conversational interfaces have come a long way from the basic chatbots of olden days. A lot more capable. LLMs have really unlocked a new level of interactivity where they're able to integrate with tools. They're able to kind of have semi-autonomous agents helping businesses automate and streamline workflows. What the world's going to need are AI engineers who understand prompt engineering, tool integration, and agentic automation. So whether you're building a simple chatbot or a more complex autonomous workflow, being able to structure prompts effectively and continuously improve the performance is essential. It's also important to pay attention to responsiveness and real-time performance to ensure a seamless user experience. These skills will allow AI engineers to design systems that are both practical and adaptable at solving real-world problems. So that's a wrap on today's episode of AI Unplugged. In our next episode, I'll be exploring vector databases and embeddings, getting down a lot more technical. It's a core component of modern AI systems, specifically generative AI. So we'll start to look at how they contribute to building more context-aware applications and why they're a key tool in the toolbox for AI engineers. Thanks again for listening. I hope you're enjoying the series. Feel free to subscribe. Catch me over on my live stream, GPT with me. Check out my blog at aibuddy.software. And as always, stay curious and keep experimenting.